Hello and welcome to episode 3 of this tiny barn build series. Now in the last episode you will have seen me finish removing all the vegetation from this area, measuring and marking out for where all of the foundations needed to be, get them dug and installed. Now in this episode I'm going to be installing the bearers onto these piles, the joists and the flooring so that we've got a completed subfloor. I'll also be going through the insulation and the damp proofing requirements for this subfloor and the strengthening and bracing that's required to ensure that this subfloor and the building it supports is strong enough to resist the earthquake and wind loading that it's going to be subjected to. Now in the last video you'll have heard me mention anchor piles and braced piles. Now a braced pile has to have a footing that's at least 450 millimeters in depth, which all of these 6 have. And an anchor pile has to be over 900 millimeters, which all of these have. So for me, these 6 can be any that I want them to be, but it's determined therefore by how much of the pile sticks out of the ground. If it's less than 600 millimeters, it can be an anchor pile, and if it's more than 600 millimeters, it has to be a braced pile. So the situation we've got here, these 2 piles here have to be anchor piles, and that's good and provides all the extra bracing I need for this structure. These 4 piles could easily become braced piles. I can make that decision later. Now I'm just treating these cut surfaces with a little bit of timber preservative just to bring them back up to their treatment level. Make sure we get a good coating on there. There we go. And to building code, if the tops of these piles are within 300 millimeters of the ground, I need to put a damp proof course on there before I install the bearer. Now these are over 300 millimeters, as are all of the others, but I'm going to do this anyway. It's a small step, it doesn't take very long, it's very cheap material, and why not put that in as an extra piece of insurance? So I'm just going to staple that on there. And that's just so it doesn't slide around as I try to attach the bearer. There we go.
A number of people commented in the last video as to why I'd chosen to use wood for the foundations for this tiny barn. Now in New Zealand it's really common to use timber piles for the foundations to houses, especially in hilly locations such as this. Now I'll talk more about this later on in the video, but one of the main reasons I've chosen timber is its flexibility in an area prone to strong earthquakes.
I'm going to nail these 2 together to give me the bearing thickness that I need to code. Line it up to the string line, it's running long. Once I've got it fixed to the piles, then I can chop it off to length afterwards. Now the fixings I need are double row of fixings or 2 rows of fixings, 1 nail every 250 millimeters, 10 inches. Nailed from both sides, so I'm going to do 500 mil centers on this side, flip it over and do 500 on the opposite side, staggering. That way we end up with a really strong join. Approximate length is there, so I just want 1 set of nails there. Okay. I don't know if you can tell from there, but we've got a slight crown in this beam, as expected, which means it's not sitting on these 2 piles. So I'm just getting it aligned on this back face, put my body weight onto it, toenail it, finish off down the end, then I can come back and put the bracketry in place to hold it tight. Right, measure these bearers for length, chop the excess off, and then I can fix them properly to the piles. Now where the pile is going to be adding to the overall bracing demand of the building, giving strength to the subfloor, the bearer to the pile junction is really quite crucial. I'm going to be installing this kit. Now this is a 12 kilonewton kit that's going to allow the junction to withstand a 12 kilonewton force in this direction and also in this direction. So I'm installing one of these plates on either side. There's going to be 8 nails into the bearer and 8 nails into the pile. The centre of this plate is roughly running through here, so that's going to be straddling that joint there. And 40 millimetres down from there, we cannot put nails in this area here because they'll be too close to the end grain of this pile. And 20 millimetres above, because the grain direction is opposing, 20 millimetres, we cannot put nails in that area there. Now, although this junction here is over 600 millimetres from the ground, where this plate will be situated, the bottom of the plate will be within that 600 millimetre boundary. So I've got stainless steel fixings going on here and the other 4 piles that are behind you. Now, I almost forgot these. A long nail that goes toe-nailed from the pile underneath up into the bearer. And you can see now why it was so important to cut this angle on the inside face of the pile, so this plate has somewhere smooth and flush to sit to. Also, it'll stop any sitting water on top of that pile, it'll just run right off. Now with these 2 short ordinary piles, these aren't going to be adding any specific bracing to the structure, and so the connections between the bearer and the pile are these wire dogs. Now they come in left hand and right hand, so I'll put one on one side, one on the other. We've also got skew nails from the bearer into the pile, and that is more than adequate to code.
I'm using treated timber for all of this subfloor structure, so I need to retreat all of the cut surfaces to maintain that level of protection. Now this is a concentrate chemical mixed with some mineral turpentine to allow it to easily absorb into the pores of the timber.
Now I'm putting this vapour barrier down underneath the subfloor, and that way any ground moisture that might accumulate won't form condensation on the underside of the floor and find its way into the tiny barn. I'm using a 200mm plastic, that's the specifications for an underfloor vapour barrier, and that way it's thick enough to resist any potential piercing from the rocks. Now I purposely put the bearers on here first before I put this down, that way I wasn't likely to be tramping on this all too much. The more I stand on it and trample on it, the more likelihood of those rocks in the ground piercing through this membrane, not something we want.
Now it would be more advantageous to use one large piece of material for this vapour barrier, but I'm using these leftovers, these offcuts, so I'm making sure that the pieces overlap at least 10 inches, 250 millimetres, and that the overlap is in a way that any ground moisture would run down over rather than under the individual pieces. And I'll be taping the joints later.
Yeah, I've only got this one little piece left, and I don't want to have to pack all the tools away in order to go out to the suppliers. It's a sunny day and it hasn't been sunny for about 2 weeks. It's rained. Now, this end of the barn is really accessible, so I could just leave this and go and get a piece later. But I think I'm going to make this work. I'm going to make a patchwork quilt, and if I want to, I can just go and buy a big piece and roll that out over the top later. think for now that's good enough. I'm going to let that dry out in the sun, and then I can come and just wipe the dust away from the joints, get some tape down, and then later on, when I've got the enclosure completed, then I can come back and trim these edges and get them pinned to something so it's neat, tidy, and the wind can't get underneath it. Okay, so this is this end of the building here. Our first joist is going to be 368 and then 600 through to the end. 368 and the joist fits there. So another 600, 968. Joist fits there. That leaves about 432 from the end of the bearer to the outside face of the first joist. And we check our drawing. Always double check as much as you can. 432, check that out. It's perfect. Right, I'm going to square those across the bearer and then, well, get some joists lined up. Hey, look at that. I'm half a mil off there. Come on, get your act together. Okay, just going to mark each of these joists now for crown, so I'm eye-sighting down the length of them just to see where the high spot is, and honestly this one's dead straight so it doesn't matter. Definite dip in that one just here, but beautiful on that side, so there's our top. And this way, when the weight of the building and the floor goes onto it, there's a potential, therefore, over time, for it to settle and become level. Now you'll notice I haven't marked out the joist locations on the opposing bearer. Now the reason I'm leaving that, it's a small building, okay? I'm going to pin the joists down in this position along this bearer here, get the boundary joists in place, and then I can square the building up. Now if I've taken my measurements accurately for the bearer from the string line, it would be accurate. But I'm using another opportunity to double check that this building is going to be square and true. So it's going to be flush with the edge of this bearer and protruding out 150 millimeters in line with this string line. However, there's going to be a boundary joist attached here, and it's the boundary joist that has to be in line with the string line. So all I'm going to do is tack this on the end here with a nail, plumb down from the string line to this sacrificial piece. Still flush with the bearer here. I'm going to take one more double checking of the measurement from the bearer to the end here. It should be 150 millimeters, and if it is, I'm going to nail that one off. And that is perfectly 150 millimeters. So I'm just getting a couple of toenails in there just to hold it for now.
Then do the same at the other end.
Now these blocks have got a couple of purposes. The first purpose is, as I've mentioned, it gives me a position to be able to plumb from the boundary string line. But they have another purpose, and you'll see that in just a moment. They're just kissing on the line. So that is the perfect position. Now that those two end joists are located, I'm just going to pull a string line on this block here right the way across, and that way I can get each of these joists into the correct location. Now why have I done that? Because of course I want to come and set these on my marks here and decide the stick out length here, the it's going to be 105 millimeters. The reason I've put the string line offset by the 45 millimeter boundary joist is that if I actually have the string line at the edge of where the joists need to be, and I butt them up to that string line, just touching, there's a good chance that each joist I do is going to push the string line further and further and further away. So we will end up with a bow or a bend. This way it's going to be far more accurate. I can position the joist on the line here, bring this block out to the string line, and when it's just touching, take the block away. And that means that if this joist is 1 or 2 millimeters incorrectly placed, that gap won't be pushing that string line out of the way. Right, so we just double check. See, just snugly fits in there, almost touching the string line. It's on my mark here, so I'm just going to toenail it. Once on this side, once on this side. Now these toe nails are only there to support it temporarily. We're going to be putting some proper fixings in there very shortly. So there we go, there's all the joists set in place. You can see that they're spaced away from the string line by the correct amount. And we can see there, just enough room for the boundary joist on every single joist. And they haven't been pushing the string line forward, so we know that they're all perfectly in a line with each other. And that way, when you eyesight down the side of the building, it'll be dead straight. Well, there's a definite crown there, look. Let's check this way around. No, okay, so that's the top. Now clearly this very long boundary joist is too heavy and too long for me to support at both ends, and I need to nail it on level and flush with the tops of those joists. So a simple fix is just to screw a piece of wood underneath here so that this joist can sit onto that piece of wood whilst I go and sort out the other end. Now I might do that, but I'm just going to try and pop a couple of nails in here just to sit this boundary joist onto. I know it's not going to be perfectly flush with the top, but that's okay. I'm only going to get one nail in at that end, then I can take these nails out and get this boundary joist perfectly aligned. Right, I've got it just resting on the ends of those nails. I'll come down to this end, line it up with the joist and nail it off. Now what's important here is it's flush here and it's flush on top. Nice. That's perfect. Right. Now I'm just marking out here the centre of the nogs or dwangs that are going to be running through this way. Now the purpose of that piece of timber that goes between the joists is to give some support to the joist so it can't deflect to the left or right, but also to give somewhere for the edge of the sheet to rest upon. Now I've purposely left the end dwang out because I don't want to deflect those two end joists. I want them to be dead straight, so again the perimeter of the building is perfectly straight. So I'm going to put those in last. I'll just pull a string line across the joists just to ensure that it doesn't deflect that joist out of alignment. Well, now all this framework is built, I just need to square it up before I finally fix it to this last bearer. And the best way to do that, because it's a relatively small structure, is to measure from the diagonals. If I measure corner to corner on both of the diagonals and they're identical, then the building is square. And so here I've got 5,385, and on the opposing diagonal 5,386. So it's out of square by 0.5 millimeter. I think I can fix that. And there it is, 5,385.5 diagonal and diagonal, both the same as each other. That means this is perfectly square. Right, let's fix it in place before it moves. Now the next thing to do is to finish off installing these connector kits. Now if you remember, we put a plate on both sides of the pile and bearer connecting the two together. Now for this kit to work correctly, and by correctly I mean resisting a load in this direction and this direction of 12 kilonewtons, then I need to install these fittings that you see here. Now these will be installed like this. There's 4 per joist on either side of the pile. So here's the thing, these brackets have 4 holes per end, okay? 4 holes into the joist, 4 holes into the bearer. And so you fill all 4 holes with the nails that you get in the kit, and then you run out of nails. Why? Well, I've just checked the specifications, and apparently you only need 3 nails into the joist and 3 nails into the bearer. So why are there 4 holes? Fortunately, I do have a pack of stainless steel annular ring nails, so I can fill in the gaps. And you know what? I think I'm going to put 4 nails in each anyway. Now there are some quite detailed specifications for the positioning of these braces, where they can be in relation to the length of the pile, how far from the top, how far from the bottom, what size hole it needs to be, whether it can be on the pile or on the bearer or joist, and the angle. Now I've marked on the pile here where this hole can be to support this brace, and it can be anywhere in between these 2 marks. Similarly, I've done the same over here so that you get adequate ground clearance. Now when I hold this brace into position in relation to those marks, it positions it rather like that. Now the minimum angle of which this can be from horizontal is 10 degrees. This is over 10 degrees, only just though. And to be honest, I want to give maximum support and strength and rigidity to this building. So I don't particularly like that. So instead, I'm going to join it onto the bearer from the pile. Now it has to be within 200 millimeters of the center of the pile, so I've got that mark on here. So as long as the fixing for the brace is within that measurement there, we'll be all good, and it will increase the angle quite significantly. Now because we're in such close proximity to the ground here, I'm using stainless steel fittings, square washers, 50 by 50 by 3, M12 bolt.
Now I know what you're going to say. Why haven't you lined up those square washers with the direction of the timber? It looks terrible. And I agree, it does. But it's much stronger. They have much more holding power. They're a square washer. They measure more corner to corner than they do side to side. And so by having them rotated slightly, you'll actually get much more holding power in the timber. Now when I originally designed this building, I did not give consideration to the ground contour. And so I really don't like how this building looks like it's floating above the ground. I want it to look like it's anchored into the contours of the land, not floating up above it. So I'm going to enclose the subfloor and then build it out to make it look like a 2-story building. Now I'm not entirely sure what that'll look like yet, I'm still working on the design, but I will show you in due course. This timber will be in close proximity to the ground, so I'm wrapping it with the DPC to isolate it not only from the ground, but also from the piles themselves. I don't want any moisture from the piles getting into this framing, and I don't want any moisture that could seep into this framing transferring into the piles and or bearers. So I'm completely isolating them, and that way they're doing their job without actually causing any problems. And I guess this is another reason why the choice of timber for the piles was the right one for me for this building. I've already mentioned the fact that they're less susceptible to earthquake damage because of their flexibility, and that is a big reason for me over concrete as an alternative. but also much easier to attach this extra substructure to. Now, I'm not saying there's anything wrong with the choice of concrete for the pile foundations. They'd have been strong enough to support the weight of the building and also would have had a durability far outreaching the 50+ years of these timber piles. But I have to consider that within the 50-year durability of these timber piles, the likelihood of a very strong earthquake in the Wellington region is pretty high. So I want to make sure that this building is likely to survive that. Now the reality is these piles will probably last over 100 years. 50 years is just that minimum durability requirement by building code in this country. And because the piles are essentially a separate component to the rest of the building structure, it could easily be supported on jacks, the piles removed and replaced in the future. And that is quite a common practice here in New Zealand for very old homes.
So I'm thinking for here, rather than just fill this in as a solid wall, it might be nice to have some kind of feature here, particularly because it's so visible from down in the garden. Now, as I already mentioned, I don't like the fact that this looks like a floating building, and so enclosing this is supposed to make it look like a two-story building of old times. So what better way than to put a window in here? Now, not necessarily a window that we can see in through, but maybe a window that shows something just behind it. I'm not sure what yet, and I don't have much room to play with because of this brace, but I'm thinking a window nonetheless. Now, I don't know what size that window needs to be. It depends what I can get hold of. Okay, so it's really just a perimeter framework I need at this stage.
Now the subfloor structure is in place, I'll be using that to take measurements for the placements of some of the other foundations, so I can afford to remove this rather unsightly batter board.
Now, when it comes to installing this underfloor insulation, it needs to be a tight fit in between the joists and a tight fit between the boundary joist and the dwang or noggin. Even so, there's a possibility for air pressure to cause that to billow or maybe even sag and drop out, and we don't want that to happen in the future. So I'm going to be installing these small plastic clips. They just get installed, nailed in place like so that the insulation sits on top of it. Now, I've set my combination square to the thickness of the insulation boards, that's 60 millimeters or 2 3/8 inch, and I'll just bring the bracket up to that position and then nail it off. Now, in actual fact, it's going to be much quicker. Rather than setting every single clip with this, I'm just going to draw a line through right now, and then I can just bring the clips up to that line. Now, insulation in a shed in a tiny barn. Why are you doing that, Dan, I hear you ask, and I'm glad you did. Now, the reason I've decided to insulate this tiny barn, this storage shed, is because I don't know what the building's going to become in the future. I know that initially I need it to be a place where I can do some jobs, some work, some repairs and so on. I also need it to be a place where I can store my bike. However, in the future, it might become an office. It might become a building where I spend considerable time during the cold winter months. So for the underfloor insulation, I'm going to be using this expanded polystyrene. It's designed for this purpose. It comes in a variety of different widths, and so I've purchased pieces that are going to be most suited towards my spacing of joists. And you can see on both of the ends, it's got this sort of concertina design, and that makes it really easy to squeeze in between the joists if it's the right size, and just as easy to just cut one of those ribs off if it needs to be a little bit smaller. Now, for cutting this, you can buy purpose tools, but they're really quite expensive, and I certainly don't have a need for one. And so the next best thing is a bread knife, which I also don't have. So I'm going to be using a good old handsaw. We'll see how this goes. Make a mark on my length here. And it is important that this is a tight fit. You don't want any air gaps around the perimeter, otherwise it's really not going to be doing its job. Oh, that's a nice tight fit, isn't it? There we go. I'm just going to fill all this out and then I can get the sheet material down before it rains again. Now these offcuts I'm certainly not going to be throwing away, and so what I'm going to do is make up two pieces that fill in this void, so I do need more plastic clips. So I'll get those installed and then I can make use of all of my offcuts. And the sheets have to be set 6 to 10 millimeters in from the boundary joist. And that's really just to accommodate for any shrinkage in this timber as it dries out. That way the flooring sheet doesn't pop the cladding or siding off the side of the building.
And I'm going to pre-cut all of the component parts before I install them. You'll notice that the noggins or dwangs are offset from the centre of the building. And that's not by mistake. It's so that I've got as many false sheets as I can get in this structure. False sheets are going to give me a much stronger diaphragm. Now I want to try and avoid sliding the sheet along the subfloor and basically wiping all the glue off the joists. I need to try and place the sheet accurately, and that's pretty hard on your own with a 19mm thick 3/4 inch sheet of structural grade plywood. The specifications on the sheet fixings is 1 nail every 10 inches around the perimeter, or 250mm, and on the field of the sheet, 1 every 300mm, or every foot. Now I'm going to go tighter than that, so this flooring is as strong as it could be.
Well, I've run out of glue and I've got it on my shirt, so I better go and get this washed, get some more glue, and then I can finish off. Now, I'm back with a new shirt and new glue. I knew that string line would get me at some point. Right, so I'm going to have to go underneath and fix that. Good as new. I'm gluing the sheet down so that you don't get any squeaks in the future. This potentially could get wet if I bring in the bike, and if been out for a ride in the rain, you know, the flooring could get wet. That could cause some expansion and contraction, and then we're going to start to get some squeaks. And that's not great. So gluing the sheets down, but also nailing them with these ring shank nails is going to prevent that. Now these ring shank nails have got really good holding power. A, because they're galvanized, and B, because of the ring serrations on the shaft. They really do have a good holding power. Come on. There you go.
Okay, so here it is, the final sheet, or part sheet as it is. Now it's important to make sure that the tongue and grooves fit tightly together before nailing the sheet off. And because I'm using treated ply for the flooring of this tiny barn, retreating all of those cut edges before they get hidden away behind the walls.
Well, that's the subfloor finished for this tiny barn. I have a decision to make though. What to do next? Is it going to be the walls for the storage area or the retaining wall for the parking? So until next time, thanks so much for watching. Bye.